grade 12 learners, welcome to today's technical mathematics lesson. My name is Matsidiso Kongwani. This lesson is brought to you by the Gauteng Department of Education in collaboration with Saibono Discovery Center. Our lesson for today is on complex numbers, as we are busy with that now, grade 12. And then the objectives of today's lesson, after the completion of this session, you will be able to, number one, define a complex number. The symbol for complex number, which is the C that you see there. And then the formula that we use to represent a complex number is formula Z equal to A plus BI. And then secondly, you must be able to work with complex numbers, including the following. Number 2.1, you must be able to use this, including the imaginary numbers. What do we mean by an imaginary number? It's where we have an I squared, which is equal to a -1. We will elaborate more on that one as we proceed grade 12. And then now we must also be able to work with complex number, including performing operations with complex number like addition, your subtraction, multiplication, division, and together with the conjugate of a complex number. And then when we note a conjugate, we put a dash on top of Z there to show that this is now a conjugate. Remember, an original is just Z equal to A plus a BI. And then also including representing complex numbers in an Argand diagram. So grade 12, you must also be able to represent this complex number on an Argand diagram. You must be able to write the complex number from the rectangular form to the polar form. And then by calculating an argument and finding the modulus of a complex number. And then lastly, you must be able to solve complex number with two variables. It's where we are having the application of the simultaneous equation, solving two unknowns. And then now, where does this complex number come from? So it comes from our number systems. Number systems, we are talking all existing numbers and non-existing in mathematics. And then now this complex number is divided into two parts, which is the real numbers represented by the letter R there. And then we have another bracket, which is the imaginary number, which is represented by II there. And then with the imaginary number in mathematics, we used to say these are the non-real root numbers. We are talking of the square root of a negative number. If you put that into your calculator, it will indicate an error. But with the technical mathematician learners, we are solving this under the imaginary numbers. But with the math learners, they stop here, indicating that the roots of this particular number are non-real. So technical mathematicians, yours is to continue giving us a solution for that one as an imaginary number. We don't stop there. And then now with the real number brackets, now this is divided into the rational and the irrational numbers. And then the notation for rational number symbol, we use Q. And then now for the irrational number, it's a Q with that dash on top there to show it is now an irrational one. Right. And then under the rational numbers, we now find our integers, we find our whole numbers, we find our natural numbers. Symbol for integer, we use Z. And the symbol for the whole numbers, we use an N with a 0 there, because whole numbers, we are talking 0, 1, 2, 3, and so forth. And then now the natural numbers, they only use an N. That means the difference between a whole number and a natural number notation is that with the whole number, we are having a 0 there, since whole numbers are starting from 0, 1, 2, and so forth. Whereas the natural numbers are counting numbers, 1, 2, 3, and so forth. With the integers, we are talking now starting from 0 going positive, 1, 2, 3, and so forth, and then now the -1, the -2, up to the -infinity, that sign. Those are the integers. So all of these, they fall under the rational numbers. And then now let's look at the definition of the complex number. Now we have indicated where does a complex come from. And then now the complex number, we also indicated it is noted by a formula. Z is equals to A plus BI. So the complex number, symbol Z there, and then the real number is a real number plus an imaginary number. So the real number in your formula is the A value, and the imaginary number is the one that is indicated by BI there. So the formula for the complex number is Z equals to A plus BI. We will be working with this mostly in this chapter, grade 12, using that notation Z equals to A plus BI. And this notation, we call it a rectangular form. Original complex notation is a rectangular form. Right, let's start with the first activity now. In this activity, you are given the complex numbers as indicated 1 up to 7 there. And then you need now to note down which one is the real part and then which one is the imaginary part. It is very important that before you start identifying that grade 12, you ensure your formula is in the format A plus B of your complex number or the rectangular form. Right, and then let's look at the first one. That the notation is correct because it's in the form A plus BI. So that means now our value of A here, it will be 2, and the value of B will be that 4 there. So now if we want to take out a real part here, because the real part is A, that means it will be a 2. And then the remaining part will be an imaginary number, on which on this case it will be a 4y. I hope that is clear, grade 12. Moving on to number 2, we are identifying the real part. What is our real part here? Check notation first. Is it in A, B, I notation? Yes. And then what is the A value? The A value is half. That means that is our real part because real part is A. The imaginary part is BI. Okay, so what is the BI here? Our BI is -2 over 3I for this formula now, on an expression. And then now number 3, look at number 3 now. We are having -2 minus 6I over 4. And then now, grade 12, so you have to identify the real part and the imaginary part, the value of A and the BI from this formula. So now we know that if we are having a division of 4, this is applicable to both your numerators -2 and -6. That means now we are having our A value being a -2 over 4. And then the BI will be a -6 over 4. Okay? So what is our A value? -2 over 4. So in a simple form, it will be -1 over 2, simplified fraction. And then now the imaginary part, it will be a -6I over 4. Remember, imaginary goes with an I. But this is not simplified, so we need to simplify that to -3I over 2. That is our imaginary part. Moving on to number 4 now, and then we want to check the notation first. A plus BI. If we look at this, we only have a 9I. That means it is representing a BI. What does that mean now, grade 12? It means now the value of A is 0 in this case. That means it's a 0 plus there. So that means our A value will be 0. And then our BI will be 9I. So the real part now is equal to 0. And then the imaginary part will be 9I. Okay. So number 5. Check the notation. You must have A plus BI. If you look at this, you have only -20. We don't have anything that is having an I. That means it simply means that it is a 0i here, because 0 times any number is equal to 0. So now we can now identify the real part is the one without an I, which is minus 20, and the imaginary part will be a 0i now. Okay, it's also acceptable if you write only 0 for itself. And then number 6 now, check notation again, a plus bi. So now look at that, that is a 5 pi. And then remember 5, a pi is the number, is 22 over 7, remember? So it's 5 times 22 over 7, actually here. Now look at pi. Do you have a pi? No. So if there is no pi, that means it's plus a 0i. Then now we have a correct notation there. We can now take out the real part. What is our real part? It's 5 pi. Anything without I is your real part. And the imaginary part, it will still be a 0i for this case. And then now number 7, we are having a square root of 2 plus the square root of minus 9. Remember now, if you are having a square root of a negative number, it is imaginary now. So now if we try to simplify this, we know that this square root 9 will give us what, grade 12? The square root of 9 is a 3, okay? So this part only here will give us a 3i, because we will be having the square root of 3 multiplied by the square root of minus 1. So square root of, or 9, sorry, the square root of 9 multiplied by the square root of minus 1. That is why we have the square root of 9, which is equal to 3 there, and the square root of minus 1 being an I, according to the conditions of imaginary numbers. Okay, now we can now take out the real part, that is the square root of 2, and our imaginary part will now be the square root of minus 9, which is equal to what? The 3i greater. Moving on to the next activity, here we are elaborating more on the square root of a negative number and the I squared, that is equal to minus 1. And then remember now, we can go this way or backwards, because if we square both sides here, we'll end up with an I squared, and then on the right hand side the 2 will cancel the square root sign, then you have a minus 1. The same applies from this one. If this side loses an exponent 2 there, the right hand side gain a square root sign, then it will be a square root of a minus 1. You only consider the positive one. We don't say plus minus grade 12. We don't say plus minus the square root of negative 1. We take only the positive one, right? And then now let's look at the activity now. The first one, as we are going through the activity, try to form a pattern around it, okay? And then if you look at these exponents here, they are all even numbers. We are talking multiples of 2, that is 2, 4, 6, 8, 10, 12, and so forth. So if we look at the exponents given to us here, they are all even. That means we are trying to come up with a pattern, okay? Now let's look at the first one. We are given I to the power 4, and then if we simplify this now, applying what is given to us on top there, if we are having a to the power 4, you can see that this application, it works when you have I squared or I to the power 2. So we are going to write this I4 as I to the power 2, and then in order to be a 4, you must raise this to a 2. It is still I to the power 4. And then according to the given information, that it stays I squared is equal to a minus 1. So we are going to substitute an I squared with a minus 1 there, but remember you have an exponent 2 there. So an exponent 2 means negative 1 times a negative 1, which is a positive 1. So we end up with a positive solution there, greater. That is our first solution. And then alternatively, we can answer the same question now. Instead of writing I squared to the power 2, we can write this I to the power 4 as an I squared times an I squared. This is still I to the power 4. Because when you multiply the same base, you add exponents. That is your exponential rules. And then now, in this case, now we have 2I squares. So we are going to substitute the minus 1. Bring 1 and minus 1 for that I squared, and then a minus 1 for another I squared. And then this now is a negative 1 times a negative 1, which is a positive 1. So we end up with the same answer as the previous one. So those are the alternative solutions that you can have for that number 1. And then number 2, we are having I to the power 6. Remember, we are targeting the I squared. In whatever we are working with, we need to create an I squared out of the given information. So here we have I to the power 6, so we are going to write this as I squared. But now to get exponent 6, it must be 2 times 3 there on the exponent. And then now I squared, now we are substituting an I squared with a minus 1. And then this is cubed. Cubed means we are having 3 negatives now. It's negative 1 times negative 1 times a negative 1. Okay? So if we say negative 1 times negative 1, it's a positive 1. Times a negative 1, that is a negative 1. So if it is to the power 3, the answer will be a negative answer. But still a 1, but a negative 1. And then number 2 now, alternative solution. We are still having I to the power 6. That means this I to the power 6. We can write it as I to the power 2, I to the power 2, and another I to the power 2. As you can see, same base, we add exponent is 2 plus 2 plus 2, which is 6. And then we can now bring a negative 1, that will be a minus 1, into negative 1, into a negative 1 there. So we have 3 negatives. Remember, 3 negative, if it is odd, that means your answer will be a negative answer there. So that is an alternative way of finding that answer for that grade 12. And then for number 3, we are having I to the power 8. You choose the method that is easier for you, grade 12. And then let's look at the third one now. Still, we are creating an I squared there. And then in order to be an 8, it must be to the power 4. Correct? And then now we bring in the minus 1. I squared is a minus 1 to the power 4. And then from there, we have negative 1s. How many of them? 4 of them. And 4 is an even number. So negative even numbers, it will be negative times negative is a positive 1. Positive 1 times a negative is a negative 1. Negative 1 times a negative 1 is a positive 1. Can you see, grade 12? If it's an even, the answer will be positive. As you can see with the first one there, it was to the power 2. It's an even number. That is why the answer is positive. Okay. Let's look at the alternative now. We are having I to the power 8. That means it will be I to the power 8 is equals to I to the power 2, that's the first 2, I to the power 2, I to the power 2, the I to the power 2. How many do we have? 2, 4, 6, 8, because we are adding exponent if we multiply the same base. So that means now we can now bring in the negative 1, that is negative 1, negative 1 for the second one, negative 1 for the third one, and negative 1 for the fourth one. How many do we have now? 4 negatives. It is even. Therefore, your answer will be positive. Can you now see the pattern, grade 12? What we want you to identify. But the second method is difficult for you to apply this method in the case where we are having bigger exponent. Like I to the power 200, it will be very difficult to write I squared until you have the ones that add up to 200. So now we encourage you to use this one because it's applicable to any power. It doesn't matter how big the exponent is. Okay, right. And then let's look at number 4 now. We are applying the first method because the exponent is bigger now, 30. Right, that will be equals to I to the power 2, but we need 30 How much must we multiply 2 with to get 30? That means you need to multiply by 15. Or you can say this 30 divided by 2. It will give you the exponent that you're supposed to write in. And then now I squared is a negative 1 to the power what? 15. And then now 15, is it even or odd? Remember, when you talk even, is 2, 4, 6, 8, 10. When you talk odd, you take out even numbers. What is remaining is odd. That is 1, 3, 5, 7, and so forth. So when you are having 15, 15 is an odd number. That means if it minus 1 to an odd number, the answer will be negative. Okay. To even number, the answer positive. To exponent odd number, the answer will be negative. Right, grade 12. Try number 5 on your own. I'm giving you 2 minutes on that one. Okay, grade 12, let's see. Grade 12, let's see how far did you go with this one. Remember our WhatsApp number, 079 454 9535. You are more than welcome to send your clarity seeking question to that particular number, or all your alternative solutions to share with others on that particular number. Let me repeat, the number is 079 454 9535. Okay, let's see grade 12. Right, we are given I to the power 100, and then now remember our target is to write this in terms of I to the power 2, and then now 100 divided by 2 is giving us a 50. That will give us an exponent there. Or you can just look for a number that you multiply to 2 to get 100. That means it is 2 times 50, which will be 100. And then now the next step, substitute the negative for I squared, and then to the power 50. Is 50 odd or even? A 50 is an even number. If it's an even number, the answer will be positive 1. Just like that, grade 12. I hope you got this correct. Okay, moving on to the next activity. We are still on I equal to square root of -1, and the I squared equals to a -1. On this one, look at the exponents now. We are given the odd number exponents for this one. All the exponents are odd. Let's check now what is the difference between the previous activity and this one. If you look at our number 1 there, remember we follow the same method where we are targeting an I squared. So we are going to write I squared in order to get a 3. That means same base you add exponent grade 12. You can't say it's I squared and then to the power 1. There's no way, because this one, it will be 2 times 1, which is still I squared. All right, we need I to the power 3 now. In order to get an I to the power 3, it will be I squared. You need to add another I here because it will be I to the power 1. Can you see the difference? You cannot add 1 on the exponent. It must be an I to the power 1, so that when you multiply the same base, you will be adding your exponent. 2 plus 1 will give you a 3. It must be able to go back to its original. Okay. Now, and then from here now, we can now substitute an I squared with a minus 1. Remember, you have an I there. And then the negative 1 times I is a negative I. That is our solution grade 12. You can't have any other alternative solution for number 1. That is the only solution for that particular problem. And then number 2, we are having I to the power 5. And then we are going to create an I to the power 2. And then if you multiply 2 by 2, it will be a 4. That means we need a 5. We are going to add an I in order to have I to the power 1. 2 times 2, 4. So we add I in order to have a 5. So now we can now substitute the minus 1 for I squared, minus 1 squared, and then I. And then negative 1 squared, remember it's a square is an even number, therefore the answer will be positive 1, I. And then which is giving us only an I. 1 times I is I. Okay, for this one you can have an alternative solution, maybe by splitting this exponent 5 into, we have I to the power 5, so we are breaking this into I squared times an I squared times an I, which is I to the power. Can you see it's the same base? We are adding exponent is 2 plus 2 plus 1, which is still 5. Now we bring in the substitution of negative 1 for I squared. For the I squared, we put a negative 1 there. For the next one, another negative 1. For I to the power 1, we can't put a negative 1 greater. We only do that if it's an I squared. Then we leave this I as it is then. And then now negative times a negative in this case will be positive 1. Can you see now? We end up with the same answer, which is only a positive 1, the same as that one. So that is an alternative method. It works well with less exponents, but the more the exponent becomes bigger and bigger, you depend on the first method of solving the problem. Okay, and then now number 3. We are having I to the power 7. We are targeting an I squared, remember? And then in order to get a 7, we can multiply this by 3. It will be 2 times 3, which is 6. And then we add an I in order to have 7. Okay? And then now I to the power 2 is a negative 1. This will be cubed. And then you have an I there. And then negative 1 to the power 3. 3 is an odd number. Can you see the application of the previous activity now, Rachel? It is now working for us in this case. A negative 1 to the power 3 is an odd number. Therefore, the answer will be negative 1. And then with the I that we are having there. And the negative 1 times I is a negative I. Okay, I hope we are still together. And then now alternatively, we can break this I to the power 7 into an I squared, another I squared, another I squared. So this is giving us 6. So we are going to add the last one as I to the power 1 so that we can have a 7. And then now we have I squared. We can now substitute with the negative 1. It's negative 1 into negative 1, the third one, negative 1. And then we have that I to the power 1 there. So how many negatives do you have? 3. Can you see they are odd? And therefore they will be negative answer there. Negative 1I, which is negative I. So that is the solution, which is the same as that one greater. Okay. And then number 4, Number 4, we are having I to the power 9. And then with I to the power 9, we can also target the I squared as we were doing on previous questions. What can we multiply here? We can multiply a 4. And then 4 times 2, it will be an 8, but we still need 1 in order to be a 9. So that is the first step. And then from there, we can substitute a negative 1 there to the power 4. And then now we have an I there. It's negative 1 to the power 4. 4 is an even number. So if it is an even number, then your answer will be positive 1. And then with an I, which is giving us positive I then. Alternatively, method number 2, because 9 is a smaller number, we can write this I to the power 9 as I squared. Another I squared is the second one, 4. And then I squared, we have 6. I squared, we have 8. And then I to the power 1 in order to have 9. Okay. And then now substitute the negative ones. Is negative 1, the first one, the second one, the third one, and the fourth one. And then that I to the power 1. How many negatives do we have? 4. It's 1, 2, 3, 4. If it's an odd, an even number, the answer will be positive 1. And then with that I, and therefore 1 times I will be an I. But with 21 grade 12, that is too much. You must write I squared until you'll be writing I squared, 10 of them, and then now having the last I there, okay? Because it's 10 of them. Can you hear the answer is already there? If it is 10 of them, that means the 10 is even. So the answer will be positive. Okay, let's check. So that is I squared with the shorter method. And then that is I to the power 10. 2 times 10 is 20. And then I to the power 1. So that it can be 21. And then I to the power 2 is a minus 1. To the power 10, and then I to the power 1. Negative 1 to the power 10, 10 is even. So if it is an even number, the answer will be positive 1. With an I, 1 times I, with an I, a positive 1. Can you see? It's a positive 1. Okay, then we are done with the powers. We now look at the negative roots. And then now let's say we are given now a root sign, a set form like that one, where they say the nth root of a particular negative a number is given to you. And then now the statement here indicates that if this n here is an odd or uneven number, an odd number is the number that is not even. That means when you take out all even numbers, the numbers that are remaining are the odd 1, 3, 5, 7. So we have real roots. For an example, we have a cube root of a minus 8 there. And then the cube root of minus 8 is a minus 2. Can you see that our n is odd there? So if n is odd, the answer will be real. It's a real number, minus 2. Okay? Remember, real numbers, integers, they fall under the real numbers. The imaginary numbers are the ones that are non-real. So if n is even now, we look at the n value there. If it's an even number, 2, 4, 6, 8, 10, therefore the answer will be non-real, of which we regard in technical maths as being an imaginary number. So we are talking to the square root of the minus 8 now. This is not the cube root anymore, it's a square root. If nothing is written there, you must know grade 12, there's a hidden 2 there. Okay, so this is even. So if n is even, that means the answer will be imaginary. Let's see now what is happening. We are going to know this as the square root of 8 times the square root of a minus 1. We are separating this. Remember, minus 1 times 8 is still a minus 8. So we are separating that into square root of 8 times the square root of minus 1. This is actually coming from the square root of 8 times the square root of negative 1, which is still minus 8. And then now after splitting that, for the square root of 8, we have an answer to square root of 2. And then now for the square root of a negative 1, remember previously indicated that if we are having an I squared equal to minus 1, therefore I will be the square root of a negative 1. So for negative square root of negative 1, we have substituted that I. So grade 12, that means now you simply check your root sign. Is it having an odd number or is it having an even number? If it is an even root, that means you are going to have imaginary answer. If it is an odd number on your root sign, therefore you'll be having a real answer now. Straightforward without an I. Right, let's look at the application now, where we are solving problems using this. And then the first one, we are having the square root of negative 144. If you put that in your calculator, it will say error. Do not use a calculator to solve this problem. Without using a calculator, grade 12, because the minute you use a calculator, everything will be undefined, okay? But with TechMath, it is defined in terms of imaginary numbers, right? And then we are having the square root of minus 144, and then we are going to write this as the square root of 144 times the negative 1, giving us the square root of 144 multiplied by the square root of negative 1. What is the square root of 144? That is 12. And then what is the square root of negative 1? That is I. So your answer will be imaginary 12i. Okay? And then the cube root now. Look at the root. This is odd. If it is odd, we are expecting a real answer now. Because number 1, this was even. That is why the answer is an imaginary number. But with this one, we are expecting a real number because it is now, the root is even, okay? The value of n is odd. It's odd, uneven, sorry, odd, uneven. Now, let's see, grade 12, how do we do this one? We are looking at the cube root of 125 now. So now this one you can just put into your calculator. It will go straight to the answer and give you the answer, which is equal to a minus 5. But if you put this one into your calculator, it will indicate an error. The minute there's an error, please check it's an imaginary one. Okay, right. Can you see now you have a real answer for that one? No need to scratch your head. We know that the cube root of 125 is a negative 1. Or you can split this into the cube root of 125. Remember, it's 5 times 5 times 5. So it will be negative 5, 3 of them. And then now, can you see now this is a cube root of that, because this one can be noted as, but it's a long method, grade 12. Even if you use a calculator, we won't see for that one, okay? So for this one now, it's a cube root of minus 5. As you can see, we are having 3 of them there. I'm just showing you where does this minus 5 come from. And then now the cube root will cancel, the exponent 3 will cancel the cube root, then you are left with minus 5 as the answer there. That is why our answer is indicated as minus 5 on the calculator. Okay, and then now look at number 3. This one is an even because it's a 2 there on the square root side. We don't know always write that 2, but there is a 2 there, showing that this is even, okay? N is even. So with this case, now we are having a negative out there, and then we are going to look at the square root of 50 times a negative 1, and then we have a minus out there, and the square root of 50 times the square root of minus 1. And then what is the square root of 50? That is 5 square root 2, grade 12, a negative outside. And then for this square root of 50, you have 5 square root of 2, because 50 is 25 times 2. So the square root of 25 is 5. And then now for the square root of minus 1, you have an I there. Therefore, the answer will be minus 5 square root of 2i. Why? Because n is even there. That is why the answer is imaginary. Okay. And then now number 4, we are having the square root of minus 9 times the square root of minus 4. So now we are having the square root of 9 times the square root of minus 1. That is 4 minus square root 9 times the square root of 4 times the square root of minus 1. And then square root of 9 is 3, square root of minus 1i, square root of 4 is 2, square root of minus I is I. And then we have 3 times 2, which is 6i times I is I squared. But remember, I squared is negative 1. So 6 into minus 1, and the answer is minus 6. Can you see now, grade 12? Because of multiplication there, it is forming an I squared, and an I squared can be substituted with the minus 1. Then the answer will be minus 6. But from that step, can you see it was imaginary? It is real because we are multiplying imaginary by imaginary. Okay. And then look at number 5 then. And then with number 5, now we can now master this with a short method, right? You can check the square root of 12 in your calculator, then set form, it will give 2 square root of 3. Isn't it, grade 12? Square root of 12 is 2 square root of 3. So if we are having a negative here, we know that there's a square root of a negative 1 there. So that means it will be 2 square root of 3 I for the first one. Multiply. We are now taking a short method of doing this. We know the square root of 4 is a 2. So we take out the square root of 4, which is 2. Then we'll be left with the square root of minus 1. That will be I. And then denominator, we are looking at the square root of 6. If you put that, you don't have a simple set form of square root of 6. It will remain square root of 6. But now this negative, square root of negative 1 will be I. So we'll be having square root of 6 I then. Okay, right. And then now we have 2 times 2 there. That will be 4. Square root of 3 I squared on top. And then denominator, this square root of 6 can be written as square root of 2 times the square root of 3. It is still square root of 6. You can check that with me, grade 12. And then we have an I on our denominator. Therefore, the square root of 3 will cancel the square root of 3 there. And then we are left with 4 on top. But I squared is negative 1. Then we are going to substitute negative 1 over the square root of 2i there. And then 4 times negative 1 is negative 4 over square root of 2i. Okay, then we can rationalize this problem, grade 12, by multiplying by square root of 2i over the square root of 2i. To rationalize this, to get rid of a square root on the denominator there. And if we multiply by square root of 2i over square root of 2i, is the same as multiplying by 1, because 2 over 2 is 1, 10 over 10 is 1, 100 over 100 is 1. So we have multiplied this value here with the 1. So multiplication by 1 doesn't change anything. So the value of this will remain the same. Now from here, now we are multiplying minus 4 times square root of 2. It will be moving up there. That will be minus 4 square root of 2i on top. On the denominator, we'll be having square root of 2 times the square root of 2, which is positive 2. And then I times I, it will be I squared. And then this will give us a minus 4 square root of 2i over 2. Remember, negative I squared is a negative 1. And then we have minus 4 square root of 2i over negative 2 there. Can you see we are busy simplifying this further? A negative divided by negative is a positive, and then the 2 into 4 2 times. So the answer will be 2 square root 2i simplified. Okay. Let's move on to the next activity. So now we are looking at the addition and subtraction, multiplication of complex numbers now. And then let's see how do we do that one. If you are adding, remember you don't change any sign there. So for the first one, now we have 2 minus 3i. I'm just removing the bracket because they always write it in terms of brackets. Plus 4 plus I. This plus sign is not having an impact on the bracket there because everything is positive. And then now we are adding like terms. So we are having a 2 plus 4, which is a 6, a minus 3i plus I, which is a minus 2i. That is our answer in a rectangular notation. Number 2. In number 2, we are having 3 minus 2i minus 2 minus 3i in bracket. So now this negative is going to have an impact on the sign inside the bracket because we are distributing now. Distributive law of multiplication is applied then. So the first bracket will remain 3 minus 2i, same as the original. Here we are having a minus 2 multiplied by 2 will be minus 2, and minus times a negative 3i will be positive 3i. So now we end up with a 3 minus 2, which is a 1, and then minus 2 plus 3, that is a positive 1i, which is I. So that is your answer, grade 12. The only thing that you must take care of is that if it's a negative, the sign of this bracket will change. As you can see, 2 was positive, it is now negative. The 3 negative, it is now becoming positive because of the impact of the negative of the subtraction. Okay, and then number 3, we are looking at the multiplication part now. And then now when we multiply, if you look at these two, they are conjugates to each other. Remember we said if a z is equal to a plus bi, its conjugate with the dash on top indicating it's a conjugate will be a minus bi. How do we see that this one is positive, the conjugate is negative? It's exactly the same thing, but the imaginary number is changing the sign, so it will be conjugate to each other. Same value of a, same value of b. The only difference is that the other one is positive bi and the other one negative bi, of which that is the case here. As you can see, the a values are the same here and the b values the same. The only difference is that this bracket is negative, the second one is positive. That means we are having conjugates here. We are multiplying conjugates. So let's see now what happens when you multiply conjugates. So we apply distributive law of multiplication. It will be 2 times 2, which is a 4. 2 times 5, which is a 10i. And negative 5i times 2 is negative 10i. And negative 5i times 5i is the negative 25i squared, because we have 2 i's there. And then now we have 4. 10i minus 10i is a 0. We are left with minus 25, but remember I squared is a negative 1. I squared is a negative 1. And then we have 4. Negative 25 times negative 1 is a positive 25. And then that is a 29. Can you see, grade 12? Your answer will always be real number if you are multiplying conjugate. Any conjugate multiplication will give you a real answer. Okay, let's look at number 4 now. And then with the number 4, we are having multiplication of 3 brackets. There's no way you can do all of them at the same time. You target 2 brackets that will start multiplying, and then after that it's only then that you can apply the 3rd bracket. So in this case, we are going to leave the first one and concentrate on the next 2 brackets. So we are having 1 plus 2i here, and then we multiply these 2 out. Please put a bracket there because you still have to multiply with the first bracket. We are not yet done. And then this is 3 times 2, which is 6, and the 3 times 3i, which is a 9i, minus I times 2 minus 2i, minus I times 3i is minus 3i squared. Can you see that? And then from here now we have 1 plus 2i. We leave that one, we're targeting the like terms on the bigger bracket there. So this will be 6. And then like terms are 9 minus 2i, which will be the 7i, minus 3. Remember the I squared is a negative 1. You can already deal with that. That is a negative 1 substituted there. So first bracket, 1 plus 2i into, remember minus 3 times negative 1 will be positive 3. 3 plus 6 will be 9 plus 7i. then you can now multiply the first bracket into the simplified second bracket. So now it's 1 times 9, which is a 9. Can you see grade 12 distributive law of multiplication is playing an important role here? And then 1 times 7 is 7i, and then 2 times 9 is 18i, and then 2 times 7i, that will be 14 what? I squared. Remember, what is I squared? A minus 1. Minus 1 times 14 will be negative 14. That means that minus 14, remember this will be minus 14 grade 12 because of I squared, okay? And then now from here, we are adding this minus 14 plus 9 there. Minus 14 plus 9, it will be a minus 5. We are automatically adding like terms. And then the 7i plus the 18i will give us how much grade 12? That is the 25i. So this is now your answer in a rectangular complex form. Okay, that is the addition, the subtraction, and the multiplication of your complex number. We have suspended the division because now division is having more relationship with the conjugate. We will bring that later on as we are doing the conjugate now. If the sign, what is a conjugate? A conjugate, if the sign of an imaginary number of a complex number is changed, the new number is called a conjugate. I've already explained that if you are having z is equal to a plus bi as being your complex number, so if you change this sign here, the bi sign, positive to a negative, the new one will be a conjugate to the original. Okay, only change the bi sign, not the real part greater, only the imaginary part. Now we want to write the conjugate of these given numbers here. We are given I, so if it's a conjugate, remember conjugate is only the imaginary part. What is imaginary part? Imaginary is the bi part on your complex number. Okay, that means in order to go conjugate, you must have an I there. Okay, now then we are having I here, which is positive. So to be a conjugate, that means it will be negative I. You change sign. And then you are having negative I here. In order to be a conjugate, this must be a positive I. And then we are having minus 4 plus 5i, which is your complex number. Our focus will only be on the bi part. That bi is positive, therefore the conjugate of this will be minus 4 minus 5i. The only sign that is changing is often bi part. Okay, and then in this case, can you see the notation now is not in the correct rectangular form? So we are going to write this as 2 minus 27i grade 12 to avoid confusion, so that we can target the correct bi part. And then in this case now, our conjugate will be 2 plus the 27i. We are changing the negative from 27 to a positive 1. And then we are having a plus ba. Conjugate for this one is a minus bi, because we are targeting the bi. Now look at the last one, grade 12. Look at the last one, the number, the last one, which is 5i minus the square root of minus 25, grade 12. Can you do that for me? Try that one on your own for 2 minutes. Okay, grade 12, let's check. Remember our WhatsApp number 079 454 9535. If you have any clarity seeking question, please send to that particular number or share all your alternative ways or easy ways of answering questions on that particular group, WhatsApp group. Okay, now let's see now. Remember I said to you the easiest way is to change this and write it in a correct rectangular form. That means in the form a plus bi. Okay, right. And then if you look at this now, we have a challenge again of this minus square root of minus 25. But now grade 12, you know what to do. This is an imaginary number. Okay, it's non-real, but on our case it's imaginary. So we know the square root of 25 is 5. That means if the square root of minus 1 is I, that means this will be 5i. So now we are having a negative from here, that negative. So we have 5i for this one. Here we negative 5i. You see that, grade 12? We are having a 5i there. I hope you are still together. It's a negative sign from our expression there. And then when we look at the square root of minus 25, square root of 25 is 5. Square root of a negative 1 is I. So that means this whole thing is giving us 5i. So we have a 5 minus 5i, which is a 0. Okay? And then if it's a 0, can you have a conjugate? Can you have a conjugate, grade 12? We are having a minus from the sign here, and then this one is 5i, is giving us a 0. Can you see we don't have any conjugate then? We do not have a conjugate because the answer is 0. Our conjugate will be minus 0i, of which is the same 0 and moving forward. Okay, so that means this is not working for us, not at all. Okay, let me repeat again. We have 5i minus the square root of minus 25. All right, then we are having a 5i. We have a negative there, and then this square root is square root 25 times the square root of minus I. So we are having 5i minus the square root of 25 is 5. Remember, the square root of minus I is an I. Can you see it's 5i minus 5i, which is a 0. That is why we don't have a conjugate for that particular problem. Thank you. And then now moving to the division. Now remember I said a division is having a relationship with the conjugate. That is why we are bringing a division below the conjugate. Now let's look at the first example. We have 15 over minus 3i then, and then now we want to simplify this complex number, and then now we are going to bring the conjugate of minus 3i. Multiply by 3i over 3i is the same as multiplying by 1. Remember, a conjugate of minus 3i is positive 3i. So we are multiplying with that conjugate, grade 12. And then this is equals to 15 times 3. What is 15 times 3, grade 12? 45i. And then negative 3 times 3 is a negative 9. And then I times I is an I squared. Simplifying this, 9 into 45 gets how many times? 5 times. And then this will be negative 5i. But remember below we are having an I squared. So an I squared will be negative 1. So a negative times a negative is a positive 5i. Or from this step, you can leave that 45 over minus 9 and write it as 45i over negative 9, and then deal with the I squared. It will be negative 1. So this is giving us 45i. Negative 9 times negative 1, that is a positive 9. And then 9 into 45 is a 5i. So we end up with the same answer. So you choose the one that is easier for you. And then number 2, we are having I to the power 12 divided by 3i to the power 3. Do you still remember? the I squared method that we applied earlier on to assist with the powers, because here we are having powers now. So now we are going to write this as I to the power 2 on top. What must we multiply 2 to get a 12? With a 6. And then denominator we have 3 I squared again. In order to get a 3, this must be I to the power 1. You must add I to the power 1 to have an I to the power 3. So that when you multiply same base, you add exponent 2 and 1 there. Right, continue grade 12. I squared is a negative 1. And then look at the exponent, it is even. Is our answer going to be positive or negative for the numerator? Positive, because 6 is even. Okay, denominator we have 3. And the I squared is minus 1. And then we have an I there. And then minus 1 to the power 6 is a positive 1 over 3 times negative 1 is a negative 3i. And then can you see now you have a conjugate minus 3i on the denominator. So we are going to take that minus 3i conjugate, which is 3i, multiply by 3i over 3i. So now on top we are having 1 times 3i, which is 3i. Denominator minus 3 times 3, that is minus 9i squared. Continue, that is 3i. Denominator minus 9 into minus 1 for I squared. This is giving us 3i over minus 9 times negative 1, that is a positive 9. So simplified fraction is 1 over 3i for that one, or an I over 3 is the same answer. Okay, moving on to the third one. With the third one, you remember that we said this 6 is for both of them. Okay, this 6 is a minus 3. We can write this as minus 3 over 6 plus a 6i over 6. Correct? And then if we simplify this now, it will be negative 3 over 6 fraction is negative 1 over 2 in a simplified form. And then 6 will divide by 6, then is plus I. This one is straight and forward. It is already at a rectangular form at that level. And then let's look at number 4 again. Same application. We are splitting the denominator equally, so that is minus 3 over minus 2i. And then minus 2i over minus 2i. And then this one will give you 1, or alternatively, grade 12, you can go straight to the conjugate rate, not to complicate your life. Ne? You can multiply by the conjugate of minus 2i, which is 2i over the 2i. Okay, and then now let's continue. It's minus 3 times 2i, that is minus 6. We are distributing this to both of this now. So minus 3 times 2i is minus 6i. Minus 2i times 2i is negative 4i squared, because there's an I there. And then denominator is a minus 2i times 2i is minus 4i squared. Continue. You have minus 6i minus 4 into minus 1 for I squared. On the denominator you have minus 4 into minus 1. Then this is giving us minus 6i. Negative 4 times negative 1, positive 4. Negative 4 times negative 1 is a positive 4. And then if you want to split this notation into a and bi, so we start with this one now. It will be 4 divided by 4. The real part will be 1. And then the imaginary part will be minus 6 over 4, which is minus 3 over 2i. Correct? And then now move on, grade 12, to the next question. And then if you look at this one now, let's write this in a correct notation now. It will be 1 minus 2i. Just write it in the denominator in a correct rectangular form. Not to confuse you, it's minus 5 plus I. Can you see your b is positive now, right? So now we are going to multiply this by its conjugate. That means it will be multiplied by what? Grade 12 minus 5 minus I over minus 5 minus I. Multiply by its conjugate of the denominator. Our denominator minus 5 plus I. So if it is plus I, the conjugate will be minus I. Okay, then let's multiply. It's like we are having bracket 1 minus 2I into bracket minus 5 minus I all over bracket minus 5 plus I into bracket minus 5 minus I. Look at the denominator. You see the conjugate? That means if you multiply two conjugates, the answer will be a real number. So we are expecting a real answer on the denominator because we are multiplying conjugate. So now distribution is 1 time is minus 5 is minus 5. 1 time is minus I, minus 2 time is minus 5, positive 10I, minus 2 time is minus I is positive 2I squared, over minus 5 times is minus 5 is 25. Because these are difference of two squares, we multiply only the first and the last. I times is negative I squared. Because when you say minus 5 times I, it will be positive 5. I times minus 5 minus 5. They will cancel each other eventually. You will end up with only minus 25 minus I squared. So continue, grade 12. Remember this one, it will be I squared will be negative 1. And then 2 times negative 1 will be negative 2. So this negative 2 added to minus 5 there, they will give us a minus 7. And then the minus I plus 10I, it will be plus 9I. Denominator, we are having 25 minus 1 for I squared. That is minus 7 plus 9I over 25 plus 1. So the answer is minus 7 plus 9I over 26. So you can split this in A plus BI form, and then this will be minus 7 over 26, and then plus 9I over the 26. So that is A plus BI format. Okay, you can write that in the simplest form and continue. Okay, right, the Argand diagram. We are now moving on to the subtopic under complex numbers, of which is an Argand diagram. A complex number is represented on a complex plane. When you talk complex plane, we are talking your Cartesian plane, the normal one that you use when you are using the graphs. But remember, in graphs, you know this as being y and x, the line y, then the line x on your axis. But with the complex plane now, we are having what we call the y line is an imaginary line, and then the x line is a real line. So your real part will be represented on the x-axis, and the y-axis will represent your imaginary part on the same Cartesian plane that we are used to. It's just that now we call this Cartesian a complex plane because we are now talking imaginary. We are also talking the real line there. So we are still using the complex number z equal to a plus bi, and then this will be plotted on that complex plane, and then the diagram that we produce there is an Argand diagram. For an example, let's look at the first complex number there. We are having 3 plus 4i, and then it's represented by a green dot there. You go to your Cartesian plane, right? This is the imaginary, this is the real part on y and x axis. So now we represent 3 on the real axis because it's an a value. So it will be 1, 2, 3 there, coordinating with the 4, 1, 2, 3, 4 on the imaginary part. Hence we have that green dot there that is representing. So if it's an Argand diagram, we'll draw a line to that dot from the origin 0, 0. All the Argand diagrams, they start from 0, 0 to a point of reference in terms of the complex equation. Now let's look at number 2, the pink dot. The A value is -4, -1, -2, -3, -4. Coordinating with +2, we move 1, 2 up. Then this is the dot we are referring to. So when you are drawing a diagram, you start from origin 0, 0 to that point. Then the line will be an Argand diagram. It's a straight line graph. And then the last one, we are having 2 as being the real number, the A value. So now it is coordinating with -4, that is -1, -2, -3, -4 on the negative imaginary line or your Y line, and then that is the dot that we are talking to there. So this is the Cartesian we are talking to, or the sketching of the Argand diagram, indicating the imaginary line and the real line. Imaginary, the real line. Imaginary, real line. Real represents A. Imaginary, it is having I. Remember, it has to do with the BI. Okay. And then now, when you go to the argument and the modulus, now the angle will be indicated on your Argand. Starting from there, we measure the angles, and that angle, we call it an argument, and is represented by beta, alpha, beta, all those notations that we use on trigonometry to present our angles. And then the modulus will be, remember, this will form a 90 degrees angle if you draw that line. And then now this R line here will be our modulus. Modulus, as you can look at that, it is an original hypotenuse side that we use in trigonometry and so forth in our triangles. It is opposite the 90 degrees angle. That is the modulus. We are just changing the language in complex numbers. Now, instead of saying hypotenuse side, we will be referring to modulus. Instead of referring to the angle theta, the angle what, we will take in the argument now. Calculate the argument. We are just referring to the reference angle of that particular Argand diagram. Right. And then now, I have already talked to this one, that it is complex, it is conjugate. So if we are looking at this, you can see that if we are talking to the original complex number, the conjugate of that will be the reflection of this one along the x-axis or along the real line, because it is now becoming negative. Can you see that? It is changing the sign there. But they share the same positive A value there, which is the real value. So that is the relationship between the complex and the conjugate in terms of an Argand diagram. Now we are representing the following complex numbers and its conjugates on an Argand diagram. So the red diagram will be for number 1, the orange yellowish one will be for number 2, and the blue one will be for number 3. So number 1, we are having 3 plus 2i. So what will be our conjugate, grade 12? 3 minus 2i is the conjugate for this one. It will be z1 with a dash on top, but it will be 3 minus 2i. And then the conjugate for z2, it will be z2 dash on top to show it's a conjugate, minus 5 plus 4i. Conjugate for z3, it will be z with a dash on top, z3. And then now, can you see this one? It's a 0. Is that one which is noted as 0 minus 5i, because the real part is 0. And then now, can you see now the conjugate will be 0 plus 5i for that one. So we are sketching these two graphs with their partners, their conjugates. So let's start with Z1. Z1, it says 3 and 2. That means A is 3, and then the B is 2. Imaginary 2, real 3. So we go real 3, we are here. And then this is coordinating with imaginary 2. That means at the point of intersection there, we will be having a dot for Z1, original. So a line to that dot is our Z1. And then now we want to sketch the conjugate of this one. the conjugate is 3 minus 2i. So the a value, the real value is still 3. And then now coordinating with minus 2 from imaginary. So the imaginary minus 2 will be coordinating with the same real 3. And then now we join that to form a line. Then this will be the conjugate of that particular complex Z1. So conjugate Z1 will be Z1. Can you see they are reflected along the x-axis? Okay. And then now number 2. We have Z2 as being minus 5. We move to minus 5. From minus 5, we are coordinating this with minus 4 from imaginary. Minus 4 imaginary, and then this is coordinating minus 5 and minus 4. We have a point there, and then we draw a line from original to that point. Therefore, we have our Z2 line. Can you see grade 12 easy? And then now the conjugate of that one, it will still be minus 5, but goes with a positive 1 now. Go positive 4, and then now they coordinate there, and then now we draw a line from origin to that point. That will be the conjugate of Z2. Draw a line on top to show that it's a conjugate. Can you see? They are also reflected along the x-axis. Original and its conjugate, reflection along the x-axis. And then let's address the blue one and see how do you sketch now if you are having a real value that is 0. Okay, on the real line we go 0, and then from 0 we go imaginary minus 5. Okay, imaginary minus 5. Can you see now this line is on top of this one? From origin to that point is on top of your axis there. So that is the complex number and its conjugate of 0 minus 5i. So its conjugate, now let's look at the conjugate of Z3 equal to minus 5. This one will be Z3. Can you see grade 12? If the real number is 0, the line will be on the axis. The same applies if the imaginary is 0, the line will be on the real axis. Okay, and then now we are having Z3 equal to minus 5i. There we have our graph. We want to now plot in the conjugate of this one. We start real 0, imaginary 5. Those are the 2 points, then we join them. Can you see that? This is still reflection along the x-axis or the real axis. That means now grade 12, this is giving us a conclusion that if you are sketching a complex number with its conjugate, they will always be reflected along the x-axis. Original will appear on the other side. That means reflection happens at the x-axis or the real axis. That is the conclusion below this one. And then now we want to look at the resultants now. The resultant when you are adding two complex numbers or subtracting two complex numbers, and see what is the difference between the two when you are adding and when you are subtracting same complex numbers. Okay, so in this case we are given that Z1 is equal to 1 plus 3i and the Z2 is equal to 3 minus 2i, and they say represent the given complex numbers on the Argand diagram. Okay, then if we have Z1, we are having 1 coordinating with positive 3 there, that is the Z1. And then Z2, we have 3 coordinating with minus 2 there, that is the Z2. Okay, we have represented them on the, okay, let me have another one this side, same diagram, 1 and 3 for Z1 and the 3 and minus 2 for Z2. Right, and then now with the first one, yellow one, we are adding, and then with the blue one we will address the subtraction part. So with the original sketching we'll be having this, what we are having now, as our Z1 and the Z2. So for 2.1, they say determine the resultant and represent them on the agar diagram that we have sketched below. And then now for the first condition 2.1, we are sketching the resultant on the condition where Z1 is added to Z2. So if we add Z1 plus Z2, we will be having what? 1 plus 3i plus 3 minus 2i, which is giving us a 4 plus I. That means this one will be our resultant, because it says the resultant when we have added these two. So now what is a resultant? It's a 4 and 1i, 4 and 1i coordinating there. So our resultant will be there. And then if you look at that resultant, it's taking the same distance of Z2 this side and the same distance of Z1 from that side. So that is our resultant then. So this will be Z1 plus Z2. That is how you write or you draw the resultant of the sum of your complex numbers. Easy, grade 12. Add them, calculate them first before you draw. Calculate before you draw. All right. Now let's look at Z1 minus Z2. What is the difference between the two now? With this one, the difference is that if you are taking Z1, Z1 will be 1 plus 3i. And when you subtract, remember now it will affect Z2, the sign of that complex number 3 minus 2i, because you are subtracting. So that will be 1 plus 3i. This one remains the same, original Z1, but now Z2 is now changing to minus 3 plus 2i. Can you see that? We are having a different Z2 because we are subtracting. All right. Right, and then let's look at the final answer after subtracting. This will be 1 minus 3, which is minus 2, and the 3i plus 2i, which is a plus 5i. And then if you try to represent this grade 12s on your diagram, we are using the blue one now. We are going to have a minus 2 coordinating with 5. That means you'll be having a point there as your resultant. Okay, but if you compare this with the previous step, then you are still having the same Z1. This Z1 is still the same at 1 and 3, correct? But look at the Z2 now. After subtracting, this is changing to minus 3 plus 2i. Let's plot in the new Z2 now. After subtracting, it will be minus 3 and the 2i. That is our new Z2. After the subtracted one, the minus Z2 is that one. Okay, and then now if we bring in the resultant, this is our resultant where we have minus 2, plus 5i, minus 2 coordinating with 5i. Can you see now this distance here? It is exactly the same as the Z1, and then this one here is exactly the same as the minus Z2. So that is how you do them differently, grade 12. Remember, with the subtraction one, you can't just go in and sketch that and have a parallelogram that is indicating that. So you need to plot in the negative Z2 first, and then now add the Z1 and minus Z2 to get the answer, and then that answer you can now bring in as your resultant. That is how you do the negative resultant. Okay, the one that is not having stress is the Z1 because it remains the same in all the diagrams. It's the same. So with this one, in order to be 100%, you are not working with that Z2, because here we are working with minus Z. That is why we are bringing that minus Z. And then now we can now calculate the resultant and then complete your diagram in order to have your resultant parallelogram diagram. Okay. Modulus and complex. When we talk modulus, we are talking the R, which is the hypotenuse side. I've already indicated that to you, grade 12, that if we talk the modulus, we are talking the R there. And then if we talk the argument, we are talking the theta there. And then now, if we have your Cartesian plane of a complex plane, we have a ZA plus BI, which is our complex number. And then we want to calculate the modulus of this complex number. We are going to apply the Pythagoras theorem that you know, that states that R squared is equal to X squared plus Y squared. The only difference is that our X here is A and the Y is B. So, but we are still talking to the R squared, which is the hypotenuse side. And then now it's just that we are changing a language to modulus here because we are in complex numbers. So if R loses an exponent, this will gain a square root of A squared plus B squared. Hence we have that R here. We only take the positive because hypotenuse is always positive. And then when we're talking the argument now, we are talking the theta part of our angle. If we are in the first quadrant, that means we'll be having our diagram there. Theta will be from here to there. And then if we complete this triangle being a 90 degrees triangle, and then remember we said X is represented by A here, and the Y is represented by B. So remember the tangent, this comes from the tan theta is equal to X over Y from your trig ratios. But in this case, it will be A over B because we are talking then, it is Y over X, sorry, that is Y over X, opposite over adjacent. In this case, it will be B over A because we are talking complex numbers now. And then now, in this case now, because theta is in quadrant 1, this will be tan theta equal to B over A. And then if we need theta here, it will be arctan and then B over A. That is what we have in quadrant 1. Hence, we are having this notation here. But if this moves to quadrant 2, you know grade 12, this is greater than 90. There is no way we can have the same answer as that one. So in quadrant 2, it's where we are having reduction 180 minus. Hence, we are having this reduction here. Minus your reference angle. That is the one that you calculated. So the angle here, in other quadrants, it will serve as your reference, okay? Now, in quadrant 3, we are having reduction 180 plus. If your theta moves to second, it's here. If it moves to the third quadrant, it will be there. So in third quadrant is 180 plus the reference angle. And then in quadrant 4, it will be 360 minus. That is our reduction in trigonometry. So that will be 360 minus your reference angle. We are still applying that in order to calculate the correct argument in complex numbers. So where does this come from now? The rectangular and the polar form. To get a polar form, we use the rectangular, or you can take the rectangular form to polar and the polar back to rectangular form. You must be able to do both. And then if they don't say polar, they will say trigonometric form. Trigonometric form and polar form is one and the same thing. Remember now your trig ratios, if you are talking to the sine theta, it will be Y over R. But now our Y in this case, remember, it's an A, right? It's a B, sorry. And then okay, let's go back to that one. Remember we said now when we have the sine theta, sine is opposite over hypotenuse, but our Y in this case is B. That is why we have B over R here, okay? And then with the cos, remember is cos theta equal to X over R. But our X is in this case is an A. That is why we are having A over R then. So now if we simplify this and make B subject of the formula, we cos this R multiplied to sine, That is why we have B equal to R sine theta. And then to have an A subject of the formula, A therefore will be equal to R. We cos this R to cos theta. It will be R cos theta. So now we are having the rectangular original form, which is Z equal to A plus BR. We want to show you how was the polar form derived from the rectangular form using your trig ratios now. Remember our A, we have indicated that A is what? R cos theta. So we remove this A and write it as R cos theta there. And then for B, we write it as R sine theta. B remove and write R sine theta there. Okay, and then the R value is the same. R is the same. That is the hypotenuse side or the modular side of this particular complex number. So now the I is because of it's a complex number. Remember, it is having an I. And from here we take R out. So we have cos theta I sine theta. Another notation, this cos theta I sine theta can be written as cis theta then, or you can use this cap for cis. Okay, so those are the three notations for the polar form. And then this is our rectangular form that we were using since the original. Right. And then now we want to take this activity where we are writing the polar, we're writing these rectangular forms into polar forms. Right. Remember, in order to write in polar form, grade 12, you must have the value of theta and the value of the modulus R. So it's very important to know in which quadrant you lie. For an example, if you look at 2 and 3, this Argand diagram will be in quadrant 1. So that means your theta, can you see theta is less than 90? That means your theta will be arctan. What? B over A. What is B? 3 over 2. And then let's check now. The answer will be what? 56,31. This diagram will assist you in terms of the value of theta. It's very important that you identify the quadrant. And then from here now we need to calculate the R, which is our modulus. R will be the square root of what? B squared, A squared, 2 squared, plus B squared, 3 squared. And you just put this into your calculator straight to the answer, grade 12. That will give us a 3,61. Then that is your R, that is your theta. And then with these two values now, we can now have our polar notation. Remember the polar notation now, it will be Z equal to 3,61 for R. And then you can write cis, your theta is 56,31. Or you can write 3,61 cos 56,31 and then the sine, I sine 56,31, it's fine. Or you can write the 3,61 with the notation of that cap 56,31 degrees there. That is the notation. And then let's move to number 3. Number 3, let's check the quadrant now. Quadrant is very important. This is positive 4 and the y is negative. Can you see that? B negative, A positive, B negative. That means it's 4 and minus 2. That means that Argand diagram lies in quadrant 4. So if it is in quadrant 4, what will happen now? Quadrant 4, you are having reduction 360 minus. Remember, if it is in another quadrant except number 1, you have to consider reduction. So in quadrant 4, our theta will be arctan, will be 360 minus the arctan of your B. B is what? 2. And then minus, you ignore the negatives there because you are looking at the angle. We don't write minus 2, we take it as positive 2. And then the A is 4. And then it's 360 minus arctan 2 over 4 into your calculator. And then this will give us how much? 206 degrees. And then to look for the value of R, we follow the same method. A squared, 4 squared, minus plus the minus 2 squared. And then into your calculator straight to the answer. This is giving us 2 square root 5. So write this in a polar form. You start with Z. It's a complex number, but in polar form, 2 square root of 5. You can write this as a bracket cos of 206 degrees plus I sine of 206 degrees. Okay, or you can write 2 square root of 5 sees 206 degrees, or 2 square root of 5 with that cap for the angle 206. Okay, let's take number 5 now. Is different. If you look at number 5, is that case where we are having 0 plus 3i, of which your real number is 0 now. Now, if we try to present this on an Argand diagram, let's see now. The real number is 0, and then the imaginary is positive 3. That means this line will be on top of your axis there. Okay, with 3 now. Can you see, grade 12? We cannot apply the arctan method. Why? Because this line is not in the quadrant. It's on top of your plane. So if that is the case, you can easily determine the value of the angle, because you know movement from here to there is a 90 degrees movement. That means we know by just inspection the theta angle there will be 90 degrees. Can you see that? Don't say the value is undefined, because the minute you put this with the arctan, it will be arctan of 3 over 0, then it will be undefined. So in such cases where a Argand line lies on a plane, you do not use the arctan. You check the angle physically, so by inspection, how much is the value of that particular angle. And then now we can now calculate the R value. With the R we can calculate, that is the A squared and the B squared. And the answer will be just the 3. Okay, R is equal to 3. Then you can have your notation, that is Z is equal to 3 is 90 degrees. Okay, minus 2 plus 0i. Can you see that one? We don't have the imaginary value there. Diagram will always assist you. Have a picture of what is happening there by drawing your Argand first. So it's minus 2, yes, on the real part it's minus 2 there. And then now 0 on the one. That means that line is on top of this one, of your plane. And then now, if that is the case, what is the angle there? Grade 12 movement from here is 180. No need to calculate. You use inspection to get that 180 degrees. Because when you say arctan 0 over 2, it will give you a 0. Okay, so it's 180 degrees for that one. You can now look at the R value for that one. And then that will be A squared plus B squared. And then this will give us a value of 2. Our R is equals to 2. And then the Z polar notation or trigonometric form, it will be 2 EIS 180 degrees, or 2 with that cap representing the is 180 degrees. Okay, and then grade 12, you can also do this using your calculator now. Remember, we are having Z equal to 2 plus 3i. For that one, we end up with the theta equal to 56,31, and then with the modulus of 3,61. So now we can use your calculator, sharp calculator, if you are using a sharp calculator. So now what do you do now to change this into a polar form? You go to your calculator, and then you press the button, put in a value of A, you press this button here. Okay, you write A. It's a sharp calculator, right? Ensure that you have sharp calculator. You type in A, and then you press this button on your calculator, and then it will show coordinate form, and then you put in the B value, and then you go to second function button, and then you go to this button here. We are targeting that R approaching theta there. Our aim is to go there, but you use this button of 8 because we have selected the second function. Then on your screen automatically it will show the R value and the theta value, indicating that theta is 56,3 and the R is 3,61. Okay, so grade 12 yours is to take that one and write it in 3,61 from your calculator, and then with the 56,30. That is how you use a calculator to find the polar and the rectangular form. So now we want to move from polar to rectangle. Now we have this notation. Now let's say we are given that 3,6 z is equal to 3,61, and then and say C is 56,31 degrees. Then you want to take this back to its rectangular form, to this form. So what you do is you put in the R value, which is 3,61, into your calculator, and then you press this button where it is saying X, then column Y, and then you put in the theta value 56,3, and then you go to second function button, and then you press 9 because we are looking for the arrow that says we are going XY now, of which X is the A value and the Y is the B value. Okay, and then now A will appear as X in your calculator. It will say X is equals to 2 or 2 comma some 0 something, and then B is equals to 3, but it will appear in terms of Y. So if it says X equal to 2, you must know is the value of A. The one that is saying Y equals 2, that is the value of B in your calculator. So you take them and represent there in your original Z equal to A plus BI. Remember, X is for A and the Y is for B. That is how you move from polar to rectangular form using your calculator. The same applies with the Casio calculator one. To write this, you start by shift Casio. You start by shifting, and then on your plus button, it is indicating polar. The aim is to change your format in your calculator into polar form. And then now when you press that plus button after shift, you'll be having polar written on your screen of your calculator. Then you put the value of A, and then you press the shift button, and then you press the bracket, close bracket button in order to get that colon there, and then you put in the value of B. After punching in the value of B, you press the equal sign. So when you press equal sign, it will give you the R value, and the R value for this one, it will be 4,12. I hope we are still together. And then your theta value will give you 104 degrees. Then you just take this and write that as polar form. Z is equal to what? 4,12, and then you can use any notation. I'm choosing this one of an L-shaped notation there. Okay, and then now polar to rectangle, we are using Casio calculator. Now you start by shift again, and then you press a minus because you want to go to rectangular. Now if you go to polar, you choose the plus polar. If you go rectangular, you choose minus for rectangular form, and then bring in the value of R. That means you put in this 4,12 for an example, and then now shift button, and then your bracket colon in order to be able to put the theta value now, which is 104 here, and then you press equal sign. Then it will still show you the X value and the Y value. Now remember, the X value is representing an A, the B value is representing the Y. The same way you did with the sharp calculator, this is how you do that, grade 12. And then lastly, we move on to the last part of our complex numbers. We are talking to Solving complex equation with two variables, you target to ensure that you have x and y into one side, everything that you have to the other side. Okay, that is how you can make your life easier when working with the two variables. Okay, right, let's take the first one here. Happy now, x and y are on the same side. Can you see what I mean now? And then we are comparing this to the other part, which is equal to minus 3 minus I. So now, as you can see now, we are relating the x1 to the one without an I. So that means the value of x in this case will be just minus 3. Can you see that, great child? And then the y1, we are relating, remember there's a minus 1 there next to I. So y, positive y will be equal to negative 1 from the I part there. Okay, from the imaginary part. You are done with the solution for that one. And then let's look at number 2. Remember we said x and y must be on the same side to make your life easier. So, okay, we have 5x there, and then we are having a yi. So we are going to transpose this minus 3 to this side, because what we need on the left you already have now. So this will be 3i. Can you see now we don't have a real part here? That means it's that one which is saying 0 plus here. Okay, so now let's decide the solution now. 5x will be equal to 0 because we don't have the real part. Divide by 5 both sides, x is equal to 0, correct? And then to get the y, we equalize this y to the coefficient of I this side. So y will be equal to 3. Those are the solutions for that particular problem. Okay, now look at this one now. This one is having x plus y and the x minus y, but this one is a coefficient of I. Can you see that? That means it will go with that one which is having an I. So we'll assume this one is the real part because it doesn't have I. So we'll say x plus y, a little bit complicated anyway. X plus y is equals to 10 because it doesn't have an I. And then now we are going to say, remember there's a minus there which will affect this bracket. So we are going to have minus into x minus y is equal to the 4, coefficient 4. Okay, we just ignore the I there because you want to solve for x and y. As you can see now, you end up with two equations, grade 12. So we are going to let either x or y be the subject of the formula. If we are taking it from there and decided to leave x, we are going to say 10 minus y on this side is our equation 3. And then we are going to substitute this in this particular equation, of which, if it is simplified, it will be minus x plus y equal to 4. So we are taking this x value now, 10 minus y, we substitute for x. So that will be minus 10 minus y plus y equal to 4. You solve as if we are solving simultaneous equations, grade 12. That will be minus 10 plus y equal to 4. We are bringing in the negative in. So we have 2y. We take minus 10 to this side. It will be 10 plus 4, which is 14. Divide by 2 both sides. Y is equal to 7 is the y value now. Remember, we are solving for both x and y, not only y. Solve for x and y. So after having the value of y, we are going to bring back this x equal to 10 minus y and substitute the y value there. It will be 10 minus 7, which is equal to 3. So now happy, we have the value of x and y. Lastly, mostly complicated, grade 12. Let's see now. Happy, the left hand side is x and y. It's what we need. But the challenge is that we are having a conjugate now then. That division where you have to bring in the application of the conjugate. The notation is correct, is a plus bi. On the denominator, we will just multiply only this fraction part with 2 plus I, of which is its conjugate. Higher level now. Then you have x minus yi on the left equal to I minus 4. Plus multiply now the conjugate is 2 times 2, which is 4. 2 times I, 2i, another 2i will be 4i, and then I times I is I squared. I squared is minus 1, remember? And then remember this solution is over. Can you see these are the conjugates? Remember conjugates, they always become real. This will be 2 times 2, which is 4. And then I times I, which is minus I squared. I squared is a negative 1. Minus I squared, negative 1. So we have x minus y I equal to I minus 4 plus 4 minus 1 is a 3 plus 4i on top. On the denominator we have 4 plus 1, which is 5. Okay, and then now if we separate this grade 12, remember it will be 3 over 5 and the 4 over 5. Everyone is taking the denominator now. So we are having x minus yi. We will consider adding like terms now. We are having 3 over 5 added to minus 4. 3 over 5 added to minus 4. That will be 5, 10, 15, 20 minus 20 plus 3. Minus 20 plus 3, that will be 17. Okay, minus 17 over 5. That is the real part. And the imaginary part, we are adding 4 over 5 plus 1i there. 4 over 5i plus 1i, that will be 9 over 5i. Okay, now we can equalize now the real part, solving for x and y now, because everything is now straight and forward. So x will take this solution, so x is equal to minus 17 over 5. Or the minus y, because y is negative there, it will take this value here, 9 over 5. Therefore y positive is minus 9 over 5, grade 12. And then this brings us to the end of today's lesson. This lesson was brought to you by the Gauteng Department of Education in collaboration with Saibono Discovery Center. See you next time. Thank you.